All right, let's jump right into this explainer. We're talking about a massive part of human intelligence that, honestly, just flies completely under the radar. We spend so much time in our society obsessing over verbal skills and math scores, right? But there is this entirely different type of intelligence quietly running the show in the background of our minds. Just think about your day-to-day for a second. Have you ever eyeballed a piece of clothing on a rack and just known it would fit without even trying it on? Or, oh, how about playing real-life Tetris when you're trying to cram a mountain of luggage into the trunk for a family road trip? If you've done any of that, you are actively flexing some very specific cognitive muscles.
Researchers call these your spatial skills. In fact, back in 2010, the renowned psychologist David Lubinsky actually dubbed this the sleeping giant of cognitive abilities. It's this incredibly powerful force in our cognitive makeup that, for a long time, traditional education systems have, well, kind of just left hitting the snooze button.
So today, we are waking that giant up. Here's our roadmap. 1. The cognitive sleeping giant. 2. Why do spatial skills matter? 3. 3 core subdimensions. 4. Measurement, a single scale. And 5. The role of cultures and norms.
Starting off with Section 1, the cognitive sleeping giant.
So, academically speaking, spatial skills are the cognitive abilities that let us manipulate, transform, and reason about spatial information. Things like shapes, locations, and directions. Basically, it's what allows us to mentally organize and make sense of the physical relationships in both real and imaginary spaces. Without these skills, navigating our physical world would be literally chaotic.
Moving on to Section 2, why do spatial skills actually matter?
Get this, the research here is wild. Nearly 80% of professions lean heavily on these exact skills. We're talking highly technical stuff, from a surgeon visualizing complex anatomy mid-operation to a pilot maneuvering an aircraft in three-dimensional space. But it's not just for specialized STEM careers. You literally use these skills every single day. You need them just to pack a suitcase efficiently, parallel park your car, or even figure out the absolute best angle for a selfie. It's woven into everything we do.
Okay, Section 3. 3 core subdimensions. Now, historically, there were dozens of different theories out there, but to keep the methodology perfectly streamlined, researchers focused strictly on 3 core subdimensions of spatial skills: spatial visualization, mental rotation, and spatial orientation. All 3 of these are about physically manipulating objects and space. Let's break them down.
First up is spatial visualization. This is your brain doing complex, multi-step gymnastics. It's the process of keeping shapes in your working memory to find a pattern, or mentally combining pieces to invent an entirely new design. Imagine looking at a flat piece of paper with fold lines and trying to picture exactly what kind of 3D box it's going to make. That takes some serious sequential brainpower.
Next is mental rotation. Honestly, it's exactly what it sounds like. It's the ability to imagine how a 2D or 3D object will look after you spin it around a point in space. Like, if you look at a picture of a coffee mug and mentally rotate it to see exactly where the handle ends up on the other side, boom, mental rotation. It's a dynamic process that evaluates how objects change in space.
The third core dimension is spatial orientation. This is all about determining your own position relative to things around you, streets, buildings, whatever, so you can navigate accurately. It's what lets a swimmer know their exact position underwater or helps you mentally map out the hallways of a complex new building just by walking through it. It's fundamentally about you and your relationship to the environment.
Which brings us to Section 4, measurement, a single scale.
So, how do we actually measure this? Well, instead of getting bogged down in dozens of historical theories or using a mismatched Frankenstein collection of old exams, this groundbreaking methodology utilizes a single, unified scale. Researchers are relying on the spatial reasoning test developed by Ramphel and colleagues in 2017. By using this one single scale, they can accurately measure all 3 of those specific subdimensions we just covered and do it in a totally standardized way.
And this image brilliantly captures what that methodology looks like in practice. Notice how a spatial reasoning task doesn't rely heavily on complex word problems. It's a purely visual, nonverbal test. This is incredibly elegant because it completely bypasses language barriers. You just look at the visual input, process the spatial relationships, and mentally select the right transformation. Simple as that.
Finally, Section 5, the role of cultures and norms.
To really figure out how our environments shape these skills, researchers are going big. They're actively capturing data across 8 completely different cultural regions worldwide. This is huge because it lets scientists see exactly how distinct cultural backgrounds, daily habits, and environments actively influence how these crucial spatial abilities develop.
and they are specifically zeroing in on adolescents right in that critical 12 to 18 age range. Why? Because that is the exact developmental window where these cognitive abilities are rapidly forming and locking in. Getting accurate data during these formative years is absolutely vital.
So what's the end game of all this global data collection? It's to establish universal norm values. And guys, these baselines are absolute game changers. They allow educators to spot learning difficulties super early, way before a student starts struggling in complex math or science classes. Plus, they help uncover hidden cognitive potential in kids who might not crush it on traditional verbal tests. Ultimately, it means we can tailor educational and STEM programs to fit specific cultural and cognitive needs.
The science is crystal clear, and thanks to this robust, single-scale methodology, we are finally ready to measure this stuff properly. Spatial skills are the bedrock of our daily lives and our future technological advancements, which leaves us with one pretty provocative question. Now that we actually know how to measure and understand these abilities, is our modern education system genuinely ready to awaken this sleeping giant? Thanks for hanging out with me for this explainer, and I bet you'll have a whole new perspective the next time you find yourself trying to pack the trunk of your car.